All right, so we're starting on rational functions, and there are several things that we're going to do on the next few videos with this information. So first of all, we're going to find the domain of a rational expression. And when we're talking about domain, we're basically talking about what values of x are okay, right? What values of x can we use for this particular expression or equations? And then we're also looking at what's restricted. What number can x not be? Because that's one that we're going to have to leave out of our domain. And so this one that we're looking at here, you can see that if I put 3 into this equation, it would make my denominator 0. And then that means I'm dividing by 0, which is undefined. We can't divide by 0. So that means my domain cannot include a 3. And so it's really all real numbers except for 3. Now we're going to use this notation called set builder notation to write our domains for this section. And we do this because it gets kind of clunky with interval notation for these kind of questions sometimes, especially if you have a few numbers that you have to leave out, a few values that are not okay in our domain. So you can see here the set of all x such that x is a real number and x is not equal to 3. So that's what that's saying, and we'll practice this. Now, when you're working on these on my lab, it's going to just have you fill in the blank for the numbers that you're excluding from your domain. So you want to be sure and practice this so you understand how to actually write these out. So let's look at the first one. Now, for the ones that we'll be doing in this class, we don't have to worry about our numerators. Now, if the numerator had something like a square root or something, that's where that would come into play, because there would be restrictions on the kind of values that you could use in the square root symbol. But for us, all we have to worry about is the denominator. And so if you look at this first one, you can see I don't even have a variable. There's no way that the g of x function is going to have a 0 in the denominator. So that means for the g of x function, my domain is going to be all real numbers, right? All values of x such that it is a real number. X is a real number. So this is basically saying in set builder notation that it's all real numbers. Right? X is a real number. I don't need an S on that. I was saying all real numbers and then put an S on the end of that. Now on the second one, the h of t function, on this one I could get a 0 if I put 0 in, right? So if I divide both sides by 3, t equals 0. So 0 is actually the only number that would make my denominator a 0, and so that means that it can't be part of my domain. So for the h function, I'm going to say t because t is the variable here, and then t is a real number, and t is not equal to 0. So with this, I'm saying all real numbers except for 0 are in my domain. So we've written set builder notation to talk about the domain for these two functions. Okay. So on the next one it says find the domain of each rational function. Again, right? Same concept. But the denominators are getting a little more messy, as you can see. So if we look at the first one, we take this denominator. Once you get used to this, you may be able to figure this out. Oh, okay, it's whatever is going to make this equal 0. So if you take your denominator and set it equal to 0 and then find x, in this case I'm subtracting 5 and dividing by 2, so x equals -5/2. And -5/2 is the only excluded value, right? That's one of the numbers that cannot be in my domain, or the only number that cannot be in my domain, because that's the one that makes the domain 0. So I'm going to say x such that x is a real number and x does not equal, or is not equal to, that's what that notation means, -5 halves. I'm having problems with making my slash through my equal sign. I don't know why. Anyway, okay. So notice on the h function, we have a trinomial in the denominator. So that means we actually have to factor this. And this one is a quick factoring one because the leading coefficient is 1. So I'm finding factors of 10 that have a sum of -7. And that would be -2 and -5. So this factors as x minus 2 times x minus 5. So that means that my two solutions for this particular trinomial would be 2 and 5. And so those are the two values I must exclude from my domain, right? My domain can include a 2 or a 5 because either of those would make this denominator 0. All right, so let me write this out. X such that x is a real number and x is not equal to 2 or 5. And you can just say, you can just put a comma there for those. When I erase, it's going slow. Okay, so that's it for that slide. Okay, so that was about finding domain, and then this is to find a function value. And so this is really just a little more practice with functions. So I'm going to find f of -5, f of 0, and f of 10. So for -5, I'm going to substitute -5 in for x. And put a parentheses around your substitution if needed. So for this one, my numerator is -7, my denominator is -10, so that would be 7/10, because negative divided by negative is a positive. And then f of 0, so 0 minus 2, and -5 plus 0. And so that gives me -2 over -5, and that would be 2/5. Now remember that each one of these is actually making an ordered pair. My first ordered pair would be -5, and then the y is 7/10. The next one would be a 0, 2/5. And then let's work on this third one. I'm finding f of 10. All right, so I have 10 minus 2, -5 plus 10. And so that's 8 over 5. So this ordered pair would be 10, 8/5. That's just a reminder that, right, I'm substituting for 0 and I'm finding y whenever I find this function value. All right, so we're up to 9 minutes. I think we can just start out with these first couple of ones, and it's simplifying rational expressions. And so to simplify a rational expression, we factor everything possible in the numerator and denominator. and then we divide out any factors that are common. So if we have the same factor in the numerator and denominator, that's going to equal 1. So those are all the factors of 1 that we remove. All right, so let's factor. And so the only way to simplify these is by factoring. So we're going to factor out a 3x in the numerator, and then that leaves me 1 minus 2x. And then in the denominator, that was a 3x. So you can see that we have a common factor. It's 3x. All right, so 3x divided by 3x is 1. And so in simplified form, this would be 1 minus 2x. Okay, on the second example, we are going to factor the numerator. It's going to be a difference of squares. All right, so that's x minus 5 times x plus 5. And then in the denominator, we could write that as x plus 5. In this case, since both signs are positive, it doesn't really matter which order they're in. They would still be the same. X plus 5, 5 plus x, those are equal, right? So our common factor is this binomial x plus 5, right? Because if I divide something by itself, it's going to equal 1, as long as we're not dividing by 0. And then my answer in simplified form is simply x minus 5. All right, so this is a good stopping place on the video, and then we'll pick this up on and continue the lesson on the next video.